Alright, in this video we're going to be going over some more advanced infinite limit questions. This first one comes from the AP practice exam from 2016. And if you'd notice, this is the first time we've seen, at least on my website and in these videos, we've seen a radical used in an infinite limit question. And so don't be discouraged. You might think, oh, those are radicals, it's going to take forever. I got to somehow solve this impossible radical and simplify. But it's really simple. So we're not going to use the formal method because the formal method of, multiplying the numerator and denominator would just take forever with this. So we're just going to instead use the end behavior model and take the highest power on the top and the highest power on the bottom. And so the highest power on the top would be this 9x to the fourth, and the largest power on the bottom would be this 4x squared. And so we can just disregard this plus 1 and plus 3. So we can just say, okay, radical 9x to the fourth divided by 4x squared. And the reason why we can, sort of forget this plus 1 inside the radical is that this 9x to the fourth is going to overpower that 1 as we get infinitely larger and larger and larger values to the point where that 1 doesn't really matter anymore. And so let's continue on. So we can actually simplify this radical now. This can be seen as radical 9 times radical x to the fourth over 4x squared. And that's just going to equal, radical 9 is 3. And then radical x to the fourth, x squared times x squared is x to the fourth. So x squared over 4x squared. And now we have the limit as x approaches infinity of 3x squared over 4x squared. You can cancel out the x squares to get 3 over 4. And that is the final answer. And let's look at the multiple choice, and lo and behold, answer B. So that was kind of, a step ahead of what we worked on in the last video, which can be seen up here, showing them in a different light. But let's take a look at a different example. I have one written down here. We have x to the fourth plus 8x plus 3 over 4x cubed plus the natural log of 13 plus 10 to the 10th. And so looking at this, if we were doing the formal method, it would be technically simple in a way that, not simple, but simpler than the previous AP practice example, but it would still take a long time. So let's use the end behavior model once again. And so the end behavior model says, let's take the highest power on the top and divide it by the highest power on the bottom, and we can disregard these smaller numbers because as we get increasingly more and more negative, these numbers right here will overpower whatever these have to add. So we get the limit as x approaches negative infinity of x to the fourth over 4x cubed. And so we're just going to simplify this down even more to x over 4. Now we have the limit as x approaches negative infinity. And so, negative infinity divided by 4, as long as we're still having more and more negative numbers, larger and larger negative numbers, we're just going to keep getting larger and larger negative outputs. So this is just going to equal negative infinity. And how much time we got left? Actually, you know what? Let's go over one more example. Let's have, let's have the limit as x approaches infinity of, let's say that. So let's take a look at this one. So what is the highest power on the top and the bottom? Well, that is 3x to the sixth inside the radical, and then 10x cubed. And so we can, we can disregard these numbers because as we're getting infinitely larger and larger values, these will continuously and more outweigh them as we go up in value. So that would be equal to the radical 3x to the sixth over 10x cubed. And so I'm sort of deviating away from integer solutions where it's very plain, cut, and simple. So we have to really be sure of ourselves that we understand how to solve these sorts of questions when we get solutions that are not really intuitive. So this top number right here, this top number, can be rewritten as radical 3 times radical x to the sixth over 10x cubed. Radical x to the sixth can be rewritten as radical 3, and then this can be rewritten as x cubed, because x cubed times x cubed, add the exponents, is x to the sixth over 10x cubed. And so we can now cancel out these x cubed, and we get radical 3 over 10. Not an integer solution, but if we really understand how to do infinite limits like we just showed we did, we will get the answer nonetheless.